Welcome to this walkthrough, this deep dive. We're going to start in a couple of minutes, give people time to jump in. As always, let's just give kind of a quick hellos and welcomes and where we're coming from. I'm Jay Miller. I'm going to be your presenter for today. I'm based out of the U.S. in Atlanta, in Atlanta, Georgia, where it is both rainy and sunny, which is I don't know how often that is in most places, but we get full on thunderstorms with it being in the 30s in terms of Celsius and the 90s, 80s and 90s in Fahrenheit around summertime. So yeah, like I said, just let folks know. Love to know where folks are coming from. Toronto, I love Toronto. Toronto's one of my favorite cities. Um, it's a great time. I'm gonna give people a couple of minutes to join in. I know we're in the lunchtime on the East Coast, in the breakfast time on the West Coast of the U.S., and dinner time in Europe. So it's definitely an interesting time to choose. Um, Apologies if I start getting into a coughing fit. I've been recovering from a little cold, but it should be okay. And I've got a good mute switch here that I can use if it gets out of control. All right, I see people still joining in. Um, Ireland and Helsinki. Um, I I haven't been to Cork, Ireland, but I've been to Ireland. Love Ireland. I haven't been to India yet. That's on my list. Well, you got to let me know. Let me know what I should be doing there around this time of the year. And then definitely haven't been to Helsinki yet, but hopefully, with Ivan being based in Helsinki, hopefully I can fix that. All right, got about 15 with this from Aachen. Aachen's always fun. You see some folks that are hosts and presenters. They're going to be helping out. If you have questions in the chat, feel free to ask them. Um, we'll get into a little bit more detail as to what we're going to be talking about in just a second. Postgres meetup in Hyderabad. That'd be fun. I got to see what our travel budget allows for. I think that would be super awesome. Maybe if I'm at a PGConf Europe, while I'm a little bit closer, I can make the flight down and participate. All right, so let's go ahead and get started. Um, as I mentioned before, I'm Jay Miller. I am a staff product advocate at Aiven. My focus at the company is very much some of our Postgres offering and some of the other database stuff. We can't see other participants or the total just when they message here. Yeah, we don't have we don't offer too much visibility in the chat there. But this is going to be a walkthrough of kind of the different flavors of Postgres as they exist. Obviously, us being at Aiven and offering kind of an open source, the open source Postgres as one of our primary service offerings. We're going to be talking a little bit about that. We're going to be talking about some other types of Postgres that you might see. And I want to specify that all of this is very much based on the knowledge that we have. So there's some pieces like I can't tell you exactly how Aurora DB is going to work from a technical standpoint because one, I've never worked at AWS, and two, there are parts of that that are just proprietary that there's no way we would know. But our hope here is to give people a baseline of if I'm building that next tool, if I'm building that next, big AI startup or the next data, massive data application, like what choices do I have out there, and is Postgres a viable option? And again, I'm going to be biased, and I'm going to tell you that the answer very much in front is yes. So before we get started, Karan, one of my colleagues here, that's helping host this, is going to pass out a poll that just kind of gives us a little bit of familiarity with who's using Postgres currently. Um, what are you using with it? Like, yep, do you use Postgres or a Postgres service? Feel free to answer that. If the answer is yes on everybody, then this is going to be a very interesting conversation. Um, if you're not using Postgres, then that's cool too. Hopefully, we can convert you. But let's dive into a little bit of housekeeping. First and foremost, we have a wonderful code of conduct. That code of conduct specifies specifically that we're going to get along here. We're not going to uh, be aggressive or slandering or offensive. If for some reason you feel as if I'm violating that code of conduct, you can use that QR code. You can use the link that Karan has put in the chat. And there are other members. I'm actually a member of the code of conduct committee at Aiven, but that I hold myself also accountable. And there are other folks there that you can reach out to if for some reason something didn't go the way that you would have expected it to from a conduct perspective. If you have questions, feel free to put them in the chat. I see that someone asked a question specifically using the platform. We can't see the other participants or the total just when they message here. Yep, that's a feature, not a bug. That's how that operates. But there are multiple, there's several of you here. The session is being recorded, so you will get a copy of the recording. I believe it's set to go out on Friday. It's got a process, and of course, we got to go through it and just make sure I didn't do anything wrong there. And then you'll also get a follow up email. There will be some links that we share in the chat as well as on the slides. The slides won't be shared, but the video will be, and the links that we include in them will also be. Um, so, with that said, let's talk a little bit about what we're going to talk about today. We're ultimately going to look at about three different types of Postgres, and we're not saying three different services. We're going to talk about three different categories of Postgres and Postgres-like services. We'll talk about some of the extensions and support that they receive, and we'll also kind of create a game plan for talking about how do we make the recommendations that we make. And I'm sure here, just based on that poll that we had with, almost everyone using Postgres, then I will say that most of you have probably heard the adage or phrase, you start with Postgres. Just start with Postgres. People have been saying just start with Postgres since the 90s. Postgres started out of a DARPA initiative, or back in the days of like DARPA and like academia, and it became an official open source project in 1995. And ever since then, me as a Python developer, I'm a Python developer by trade. I've been a Python developer for over a decade. And for the last decade, people have always been telling me, start with Postgres. You need a database, Postgres is the place to start. Um, Now, granted, I didn't listen to them all the time. I've definitely gone and played with a few other sources, but I can definitely tell you that now I agree in the same way. A little bit about me as well with that is I mentioned Python development for the past 5 years, developer advocacy or 10 years, developer advocacy for the last 5 years. And I'm also a member of the Postgres Association in the US, as well as several other Python organizations. So I spend a lot of time talking to people about where to start and how to start. And I can say with full confidence that I believe that you should start with Postgres. We're gonna be talking a lot about what is and what is not Postgres. So I'm gonna say Postgres is always atomic, consistent, isolated, durable. You'll see ACID compliant. That is what ACID stands for. the data that you put into it, your tables, your columns, these are typed. So the information that you put into it, you should tell it what type of data it should be receiving. It standardizes on SQL and the SQL language. There are some minor differences, and they're always adding to the PostgreSQL language, but it's standardized on SQL. To confirm, the event is going to be 1 hour. It's not 2 hours. I don't know if my voice will hold up for 2 hours. But yes, it standardizes on SQL. It's relational and it describes that relationship. So when we're talking about how data talks to one another, that is a set and defined relationship. That's kind of some of the things that you'll see that are different. Obviously, NoSQL databases, there can be relationships, but often there is no defined structure or defined schema in how does this piece of data relate to this other piece of data. Often you are doing a lot of that stuff on the fly and through the query language itself. Postgres is lightweight. It's incredibly lightweight. I was just telling someone earlier today, I believe the power of Postgres is that it is as easy to set up where on my Mac, it is one command, brew install Postgres, and it works. And it doesn't take forever. It doesn't take a bunch of time to build. I don't need multiple servers, but it can scale. Just because it's lightweight doesn't mean that it's not scalable. It is extremely scalable to several clusters with high availability and many other features. And lastly, it is extensible, and because it is open source, it is forkable, which means if for some reason Postgres is not doing something the exact way that you need it to, you always have the ability to fork it and or extend it. You can add functionality to Postgres, or you can modify the Postgres database itself. So when we talk about Postgres, those are the things to keep in mind. So now, when we're looking at like different flavors of Postgres, we've kind of put them down into three different categories. And that is Postgres itself, the elephant in the room. I always say people look for the elephant. If you see the elephant, hopefully you've gotten actual Postgres. This is the tried and true Postgres. Then you have Postgres forks. Um, these are usually services that are built on top of Postgres. They're slightly modified, again, as I mentioned before, maybe to fill in a gap that Postgres has. I don't think there are a lot of gaps that haven't been filled, but as new technology comes out, people create newer and newer ways to solve them. And then you have what are called Postgres compatible services. And we're actually going to start in that area, the Postgres compatible. Compatible is I don't want to say a loaded term, but it's definitely a phrase that can mean different things. Compatible means that you're not only can I write like Postgres code, but maybe I could write other code. I was at Microsoft before I was at Aiven, and Cosmos DB was a great example of this, where you could store everything in Cosmos DB, and I could write you depending on whether or not I was using the SQL extension, the Postgres extension, the MongoDB extension. There's different ways that I could access that data and different wrappers around that data, but the data itself wasn't sitting in Postgres. It was sitting in some other data service or data store that Microsoft had built. Same thing with things maybe like Aurora DB from Azure and some other services like Yugabyte. These all offer a way to speak Postgres to this data, but the data itself may not be living in Postgres. And the big difference in that is possibly what is happening under the hood. Obviously, anytime you're writing a wrapper on existing code, there's going to be some latency in that and just how you transform that language from one to another. But also, it may not be optimized to handle Postgres like commands. They probably want you to write it in whatever they wrote it in, to make it easier, or use their structured query language. So just as you're thinking about things that are PG compatible, when it says PG compatible, think about what that means. Um, Compatible doesn't always mean the extensions. It just means that it can understand you writing PostgreSQL, the PostgreSQL language to it, and it'll offer your data up. And it may offer it in a way that looks like Postgres. And that's where compatible is kind of a fuzzy phrase. And there are times when you should definitely consider compatible data. I kind of mentioned it before, like having something like a MongoDB. Like MongoDB was the first database that I ever used. And for me, if I had a bunch of data in BSON format, nowadays I can put that in Postgres and use some of the JSON support that has come out over the last few years. But before that, I couldn't. I had to put it in something else. But maybe I want to interact with it in alongside Postgres data. Maybe my application uses Postgres, but my data layer comes from many different areas. I'm using something like PsychoPG if I'm a Python developer. So I think there are definitely use cases where you might want to consider a PG compatible database. But I would again just think about that throughout the rest of this conversation, that maybe modern Postgres will fit your needs a little bit better. Also, maybe some of the other reasons you might want to switch, you might want to go with the PG compatible database, is they may have some feature that is provided by that service that is just more important than the long-term compatibility with Postgres. A lot of that's going to depend on your development team. It's going to depend on your engineers. It's going to depend on your application. You might need that feature that they have, and you might be willing to write code, or you might be willing to change how you query your data in the long term if they decide um, that they're no longer going to be PG compatible, or if they're deprecating some of their functionality for PG compatibility. Again, that's not to say that there's any companies out there that are doing that, but you have to keep that in mind. That is an added weight or pressure that puts on your engineering team when you're making that choice. So we talked about like the true Postgres, and that's just straight up PostgreSQL, the same thing you get when you brew install Postgres. Often with this, what you'll see is it's Postgres, and then there will be some type of app layer above it that allows you to access and work with that Postgres database in a preferred way. Now, obviously here, me being at Aiven for Postgres is that example. What we offer is Postgres. It's not a fork of Postgres. It's not our own special flavor of Postgres. It is Postgres. The things that we do to kind of separate ourselves from what you might get from a standard Postgres is, one, we put your data right next to the rest of your data. So if you're using Postgres with other databases like OpenSearch, or with a streaming platform like Kafka, we make it really easy to administer, login, control, single sign-on, control auth, and all of those applications together in one spot. So it's all of your data in a unified control plane. That is kind of the Aiven promise. And we also allow you to choose your cloud provider. So of course, when you're working with Aiven, that means you're hosting your Postgres, your Aiven for Postgres instance on something like an AWS and Azure, or if you are interested in something like data sovereignty, we have some other cloud providers that can ensure that your data, your information sits in the region that you need it to be in. So ultimately, we're giving you the tried and true trusted Postgres with all of the options and availability and customizability that you want. And because it is that Postgres, you get no vendor lock-in, easy in, easy out. It's easy for you to migrate your data in. It's also easy to PG dump and send your data out. You get what's on the tin. You know what we're offering because we're offering what Postgres is offering. If you look at the features that are in the Postgres changelog, then in many ways you should be able to develop to use those same features. Um, and that also makes our lives easier because we are using the open source Postgres. That means we can develop with what is being actively developed for by the Postgres community. So as Postgres continues to innovate and change and evolve over the next few years, that gives us the ability to see that roadmap, be in the conversation, understand what's going on, contribute to it, but also understand where it's going and work towards providing support for it. And flexibility with parameter tuning as well. Exactly. I believe there was a blog post that just came out from a company called DBTune that mentioned, hey, they can run on Ivan purely because Ivan is running. We're running actual Postgres, and DBTune is awesome, and we have a AI offering as well that kind of works with both of these. But the beauty of those features and services is that because they don't have to do anything special or different to work with us, it means you get that flexibility. You get the flexibility of choice. Again, no vendor lock-in. Um, and if you want to learn more a little bit about like some of the different things and benefits that come with that, our colleague Dirk actually wrote a great blog post recently about the different performance benchmarks across our cloud offerings. And this is why I feel like it's so important to have that easy in, easy out. Um, yeah, for a few parameters. We took a look at what the some of the benchmarks are for the many different cloud providers. I believe the at least the big cloud providers that we have, and talked about what does it look like on from here to here at different scales, at different performance levels. It's a really great post. Uh, you should definitely check that out. And the beauty of that is, again, because no vendor lock-in, with Aiven, we make it super easy. You can just one click migrate that data over to a different cloud provider, and it goes in, it goes out pretty well. So we talked about developing for the future. Let's talk about the developing for the present, which is looking at Postgres in 2025. We had some really awesome features here. This is a pretty short section. We have some features, we have some extensions. Most of the features in PG17 have been really, really interesting. My personal favorite, JSON tables. Again, I mentioned before, I have this mixed relationship with dealing with JSON data, and JSON tables made it much easier for me to take some of that data that I'm ingesting at a large mass, taking some of log data, taking some of the data that I use for flat files, taking things like transcriptions and other pieces like that, and getting all of the metadata and putting it in its JSON format and just operating with it later on, and then using it as if it were a normal table in Postgres, using those virtual tables that are created when you do a JSON table. Again, some of the multiple improvements on replication, on cleanup, the performance improvements just on the vacuum operations were absolutely phenomenal with the TID store that got added in PG17. And then, of course, a lot of different things in making optimizing commands. I think one of the things that I really enjoyed about the some of the improvements this year is, as a web developer, first and foremost, I often am using an ORM, and ORMs have this flexibility of doing different commands in different orders. And order has always mattered in a lot of cases for Postgres. Well, one of the new features actually made it so that, like, if you did things in a certain order, it just said, okay, I got you, and just makes it just works like right out of the box. And again, there's a blog post from my colleague Jeremy who not only talks about some of the features in the last update, but over the last 5 years across all of the supported versions of Postgres currently. So feel free to check that out. Maybe you're using an older version of Postgres and you just want to know what's different about it. Lastly, we have some of the popular extensions that are available, not just in Aiven for Postgres, but across all of the Postgres instances. Some of them are actually, I don't think any of these are included by default. They are included by default in Aiven for Postgres. And again, that's not a fork. That's just a part of the setup processes. When we spin up your database, we have extensions that we will make sure that are included. The extensions that we include are not always the same as what others will include, but that's definitely kind of one of the control plane different pieces of it. It's still the same Postgres, but these extensions that you can add on, we include all of these by default. Others you may have to install. So we have PG Vector, which has become kind of the golden child lately in the era of dealing with AI and AI data and vector search. Um, a good friend of mine, Pamela Fox, who's at Microsoft, and I were talking, and what we've learned is that as we're trying to teach more and more people how to use AI and to do these really awesome things with data and bringing data in for RAG and agentic ideas, what we've learned is we've just made people really good at searching techniques. It's not necessarily that we're building anything like revolutionary, but instead what we're doing is we're leveling the playing field on how to do amazing things. And full text search has kind of always been like the one thing that when it got added to Postgres, I was like, oh, this changes everything. And then PG Vector came out, and people were like, this changes everything. I can't wait for us to start talking more about hybrid search and combining PG Vector and full text search. And if that's something that you want, like, let us know. Give us that feedback. That would be fantastic. But PGF Vector gives you a couple of different algorithms that you can search by. It allows you to create these vector data types for one of your columns. And then from there, you're able to do things like perform vector search. PostGIS is one of the more foundational names when it comes to Postgres extensions. It offers you that geospatial data type and that functionality where you can do things like build geofences. You can do things like calculating distances between two geopoints. Basically, it is one of the underpinnings for a bunch of different open source projects around data, including open map data, the open map data type. So that's great. And then Timescale, brought to you by the company formerly of the same name. As of yesterday, they are now Tiger Data. Uh, kind of started working on what if we looked at this data from a time series standpoint. What if we started doing things that would allow for rapid compression. And really, the last two things they've done, timescale and PG vector scale, are both of those. Timescale giving us great time series data operations with much faster throughput, but PG vector scale being that new kid on the block that's built with PG vector as a dependency to allow for different types of different algorithms that allow for great compression, which means you can work with a lot of data and still be able to get excellent performance for your AI workloads. So, in the spaces, in the very few gaps that Postgres still has, things being solved, there are some great teams that are there. And if you want to know more on that, again, we have a blog post that covers the Postgres extensions that you need to know. There was a question in the chat about the slides rather than the session. Just due to how we build the slides, it's not really reasonable that we could share them exactly like that. All of the links and references that I'm talking to, we have written these wonderful blog posts, and we are going to share the links as well. So you're still going to get all the information. You won't have to necessarily re-listen to the entire session just to get the few gems. most of the information that are in these slides we have put in a series of blog posts that we're going to share with you. All right. So moving on to some of the forks. Again, fork isn't necessarily a bad word here. This is often a situation where we've identified a gap, and in order to solve this problem, we've really started to work and provide some type of solution in there that is like, oh, it's Postgres, but we've added this piece onto it, or it's Postgres, but we've modified it so that it operates in a different way. And at Aiven, we actually do have one type of Postgres that is a fork of Postgres, and that's Aiven for AlloyDB Omni. This was developed by the folks over at Google, and the Omni part of it, Google has AlloyDB. The Omni part is the embedded version of this that allows you to run it on currently the three major cloud providers, AWS, Azure, and Google Cloud, of course. So when we talk about like why they needed to fork it, one, uh, it allows for them to do a couple of things. There's a decoupling of kind of the storage layer, which we'll talk about in just a second, but also they've really managed it. They've managed to build a Postgres that is designed for working with AI workloads and other like large machine like data workloads. So when we look at from a very high level what Postgres looks like, you have these client processes that pop up, you have these background processes that are happening, and then you have system memory and file storage. What AlloyDB Omni was able to do was keep all of these things and modify it ever so slightly. So they added a page caching with the container runtime on the kernel. They added that columnar cache built in, and they have a bunch of engines and processes that run for making this kind of the tool that you would want to reach for, in particular AI components. Now, again, we put from what we can tell, because as you saw in the last slide or couple slides ago, AlloyDB Omni is proprietary. That means we only have the visibility of what Google allows us to have. But ultimately, what we've seen is their commitment to saying, hey, it's going to be 100% compatible with Postgres. We've added these features on. From what I can tell, that seems to be true. Um, and having it built in the way that it does makes it really easy for you to start working on these AI and ML supports. But again, kind of the way that they've done that is through kind of forking and modifying. So they don't use PG Vector. Instead, they use their own modified version of it called Vector. That does give you the ability to query remote models. It allows you to integrate with the Vertex AI model garden. If you haven't seen the model garden, it gives you a bunch of different tools, a bunch of different AI, large language models, other models, other machine learning models that are available. They also allow you to connect to models that are provided by Hugging Face. And all of this is from within SQL itself. So you don't have to do any type of like ETL. You don't have to like pull the data out. You don't have to like write custom code to integrate with it. Everything is supported within the Postgres query language, and then added AlloyDB's commands that they have added with their fork on top, which is really nice innovation in that essence. They've also added a columnar engine. So again, if we looked back at those extensions that we had, you could see a lot of what they've done is they've taken those most popular extensions for doing these AI workloads, and they've made it available to built in, like built into the system itself, and designed to work in the system itself. So you're not just looking at, I need to add this, I need to add these extensions. They're already there for you. You just call on, you just use them, and they exist. So the columnar engine itself is really cool. It's very much like doing the time series data. They also have what's called an auto columnarization, which allows you to start building some of that columnar data automatically based on the schema that your database has. And then at that point, you can use that to, you can further optimize beyond there. But I think that's kind of an excellent way of doing it. Of, if I have to do some time series data, I need to do some columnar data stuff, I can, and I don't have to think too hard about it. But I also have the flexibility to make those choices specifically, if I wish. But I do want to preface this that, like, AlloyDB is an OLTP database. It is not an OLAP database. It's not a on. I can never remember language object language analytical process. If you need a dedicated analytic style database, um, this is not going to be that, but it is going to be a traditional OLTP database that gives you some of those analytical features that you might be wanting to reach for. So if you're thinking of maybe making a migration or a move based on, this niche use case, or if you're thinking about duplicating your data in multiple places so that you can do OLTP workloads and OLAP workloads, um, AlloyDB Omni gives you the ability to do both at some scale. And if you want to learn kind of the differences between those, then as promised, there's a blog post that is based on understanding the differences between Postgres and AlloyDB Omni and why you might reach for one versus the other. All right. Before we jump into our third category of these Postgres forks, or I guess the next category, these Postgres forks. Again, I just want to briefly mention that, like, these are not products that are provided by Aiven. That's not to say that they are better or worse than anything. It's just that we can't speak to them at a high detail, and we can only go off of the information that we know. But if we look at AWS, AWS was kind of one of the first people to start thinking about the idea of this idea of decoupling and making it so that you could build databases that ran serverless. This is great for when you have the ability to do a warm start or a hot start, because this meant that Postgres became faster. Your data always persisted in one area, and then all of the compute processes persisted in another, and that made it really easy. But again, I always laugh at the, like, if you've ever spent any time in the AWS console, you understand that sometimes you have to understand what you're actually signing up for. Just because you typed in Postgres, now you have a few more options to choose from. Um, Amazon's RDS Postgres is a fork of Postgres. This is somewhat similar to what we're doing with the Aiven for Postgres, but it is a fork of Postgres with its own modifications to it. Amazon Aurora Postgres is a serverless version that is a drop-in replacement for Postgres. And then Aurora DSQL. I'm not too familiar on the technical specifics there, but it is advertised as a serverless database that has Postgres compatibility. So again, you're gonna run into some interesting gotchas when you go down that road of compatibility space. So I talked about the idea of decoupling compute. We saw this with AlloyDB Omni, and we've seen this in kind of the serverless builds that we're going to talk about here with Aurora and Neon. The situation when we looked at that graph is that you have all of these things: the customer compute, the background services, and then you have that data layer, and they all exist on one thing. And that's okay. That's not a bad idea. But that means that when things go down, they all go down. So if you have a problem with the background services, you have to take everything down and bring everything back up. The idea behind providing Postgres compatibility but decoupling the storage is you can keep the storage up and you can isolate some of those other services so that if one goes down, only that piece goes down. That's a great idea in theory. So like we talked about Neon is serverless, it is distributed, it allows you to interact with it the same way, and it's heavily based on Aurora. But you select your Postgres version, they try to offer compatibility version for version, and it's only available on Neon services. So you only get these features when you use Neon. But let's take a look at some of the unsupported features. Again, extension support is varied because the extensions are designed to work with Postgres. They're not designed to work with these features. So usually they will have to create their own forks, their own versions, or their own flavors of doing the same thing. Not all the time, sometimes. You'll just have to, it's kind of a try or review what extensions they support before you go. Some flavors like DSQL only support single database. So if you want multiple databases inside of your instances, those just completely eliminate those options. And then as I mentioned, again, anytime I see the word compatibility, that makes me think that not all of the services, all of the commands, all of the capabilities are going to be, and all the performance, improvements and optimizations are going to be available for each of these roles. So again, not to dwell too much on that. When you would these are Postgres like, they are ACID compliant. They have defined data types. They adhere to a standard. They are relational. Usually they're lightweight. We can't really tell you too much because again, we can't see the code, but they're ultimately not open source. Neon does have an open source, but it isn't necessarily usable from an open source. You can see it, you can understand what it's doing. I don't know of anybody that's ran it and deployed it in production, and I don't know if that's within their licensing guidelines. I haven't looked at Neon's open source license in a minute. And then both the extensibility of them are limited. So at this point, we've talked about all of these different types of Postgres. The last part is, again, the little bit of guidance that I can give you, and then we'll have a couple of minutes for questions. I talked about starting with Postgres. So this is great when you're saying, if I've got a brand new idea, I've got a bunch of data that I need a home for. Maybe I'm just starting building a brand new AI ML pipeline. I don't want to make any hard commitments to one particular service. As we mentioned, I forgot to mention this. I'm sorry. With Alloy DB Omni, obviously the agentic garden, the AI garden that they offer, most of those services are going to be running through Vertex AI and Claude, or not Claude, and Gemini. I can't remember the names of them, but so that means if you want to integrate with another large language model or another machine learning model that uses something different, if you want to use something other than IVF or HNSW or IVF flat, you're going to bump into some hard walls there, and then you will have made some commitments at that point. If you go down the road of Alloy DB, you will probably already signed up for Vertex AI. You'll have your GCP account. You'll have all of those things set up. Sticking with just Postgres to start with, and then adding the extensions that you need to continue on, to me is the best approach, and probably the approach that you can stick with. So I would say you don't necessarily want to, like a lot of folks I will see start off with maybe like the serverless Postgres, or they'll start with I'm not going to say it's whatever is cheapest, but there are a lot of posts on Reddit that talk about the price of Neon. I love how they talk about a lot of like a lot of I think 80% of Neon's new databases or new tables are spun up using AI, and it's like that was the same thing that made Heroku like shut down its free tier. So there are some issues that come with the like the easiest version to start with or the easiest version to integrate into your application, or the free version that does that. Again, Postgres is incredibly inexpensive from a data standpoint. Databases tend to have a high expense. Postgres is actually one of the only services that Aiven can offer as a free tier for you to start with. So there's nothing wrong with starting with Postgres, understanding what your exact needs are, what you're going to need, what you're going to want to develop towards, and then making the choice later on to say, I know what I need, I know what I have. Now let me see if there is a service or there is a feature that another service has. Let me verify first and foremost that it is going to do all of the things that I need it to. Let me verify that the commands that I want to run are compatible with whatever this version is. Let me verify that my um the extensions that I'm coming to rely upon are available in this version. Let me make sure that it has the solid backup and resume and like compatibility with some of those things that we haven't talked about here when we talk about different extensions that are available. It's always interesting to see how an early decision can have pressure on your application that locks you in to a particular technology, which is why I kind of implored the idea of like just start with Postgres, run with Postgres as long as you can, run with the true version of Postgres, and then when you feel like you need that feature that some other service is doing, you can go in and make that decision in an educated manner. So that's going to wrap it up here. I'm going to take questions, but before I do, I mentioned before there were a couple of blog posts here. Karan's been doing a wonderful job of including them in our chat. If there are any questions, I'm happy to answer them now. They can be either about Postgres, kind of the direction of Postgres, or maybe some of the Aiven specific offerings of Postgres as well. We'll hold for say a few more seconds. I'm going to take crickets as Jay. I did a wonderful job of presenting this, and everything is clear cut and dry. And we all know now what to do. We all know to start with Postgres. We know how to go there. All right. What are all of the high level value props that Aiven PG can offer? I mentioned this kind of at the beginning. I think the biggest thing that Aiven offers you as a service is your data will exist in Postgres, but over time, there will be other pieces of data that begin to exist. There might have multiple Postgres databases that begin to exist. But you might also have to reach out to other services. You might look at something like a Kafka. You might look at something like OpenSearch or ClickHouse. The fact that Aiven is an open source data platform, it means that a lot of those different services that you will get when you start building out all of these things, PG will integrate with relatively easy. So I love to talk about those one-click integrations. Oh, hi, I have my Postgres logs and I have all my other logs going into OpenSearch for ingestion or ClickHouse for analytics. How do I get my Postgres in there? I click one button, or I included it's like 3 lines of code in my Terraform, and now by Postgres is sending everything to, you know, to open search. Again, Dirk mentioned it, migration scenarios, change data capture with Kafka, putting everything in one platform, knowing that all of your admin, so, integrating with SSO, your developers will have access to the tools that they have, the tools that they need, only the tools that they need, not more. Um, I think the idea of, again, we talk about AI insights, but not just that, but like the ability to say, I need to create custom admins that go in. Is there an option to create extensions that are not available or supported on Aiven for Postgres? The option to create an extension, you can install extensions that are not built in by default. Um, no, not yet. Dirk, am I answering that incorrectly? Feel free to come in and you can come on and join. Dirk is one of our engineers, by the way.
Can you hear me? Okay.
Yes.
No, we have a specific set of extensions as all other cloud vendors, but um, the matter of fact that we discuss with customers the need and the requested extensions, there's always a growing part in it. So if you have specific extensions missing, then we always discuss, and we are way more flexible than large hyperscaler offerings, and the chances to get a extension which makes sense in our offering is higher than with other offerings. So that is what we are doing. Yeah, that is the list of extension we are offering.
Yeah.
So we cannot just add all extensions out there. That is impossible, and that doesn't make sense. We are trying to bring in the extensions which are actually we got requested by customers and prospects, right?
Yeah. And a lot of that is just, balancing the needs of many, I guess, in there. And again, I would also suggest, like, if you are an Ivan for Postgres customer, um put it in there like, hey, I would love support for this. um I do believe that there is some level of flexibility and modifying your Postgres instance to fit you as a customer. Again, a lot of that depends on service level, SLA, like all that stuff, that I can't speak to specifically. You said you can live with that. If it's a custom extension with source code in house, maybe it could be put in as a series of SQL functions. Yeah, that's a that's an option as well. Um, awesome. Uh, I missed a question here. I want to keep using standard Postgres, but build an architecture where I can scale or isolate compute independently of storage. What tools or patterns would help me do that in an open or vendor neutral way? Um, well, I had a suggestion for you until you said in a vendor neutral way. At
Re-
that point,
rebuilding rebuilding Neon for your own and make it open source.
yeah, that is the ongoing. Dirk, we were talking about this earlier of like there is an amazing, there are a lot of people that are trying to revolutionize the like Postgres backend, and like the decoupling of storage is like this thing that I keep seeing popping up, that like I wish instead of us constantly rebuilding that same functionality, that we kind of just sat down and said, okay, like Postgres contributors, Postgres core developers, like, is there a way? Is there like a conversation that can be started that looks at what is the best possible way of decoupling these things? And again, like, never say never. A lot of people said that they would never drop the gill in Python, and then like that's the thing that's happening now. So
There's a reason why the classical transactional relational databases are there and being built so conservative. So all the serverless and storage independent stuff is pretty niche still today, even when everyone is requesting this. And there are, if you are going this path, there's also a room for thinking about other architectures or technologies instead of sticking with relational databases. And that's my personal
yeah.
opinion,
Eh,
doing database engineering for a long time now.
And Artem, you're going kind of in the direction that's like the opposite of what people would normally do. Where like I know Aiven for Postgres allows you to add on storage. So like you can scale your storage independently from your compute, but usually I don't see many services out there that have, tons of processors and low storage amounts. Um, so yeah, that's an interesting approach there. All right, everyone. Well, oh, I love how when you ask you get the first question out, and then all of a sudden it's question after question. I love this. Does Ivan PG support RIN anyway in creating data modeling? Is RIN a specific thing? Or is that a typo?
I'm also not aware at all.
Typo. Oh, okay. Okay. Does Ivan PG support in any way creating data modeling? I can't. We have a data flow tool that you can use. So like once you've actually built out your architecture, you can visualize what that looks like and where all the data is like connected, like the different databases are connected to each other. But I wouldn't really necessarily call that data modeling.
I guess I guess if you are going into data modeling and developing this stuff, I think no one wants to stick in kind of a console-based approach. So there are tools out there like dbeaver, for instance, which are pretty capable of doing this and using the Ivan database directly, right? So Ivan does not provide this, but it wouldn't also not making sense at all having this somehow integrated there, right? Because there are really good developer tools out there doing this, and you can always directly connect, so that is not a problem.
Let me see if I can find a link to that data flow tool.
Yeah, that is
I have
basically for the whole platform, showing who is integrated, which Kafka connect and so on, and who is sending data wherever. It's not the data modeling in the database itself, I guess.
Yeah, no. Let me see if I can. If it'll let me change this. I do have an example that I can put up on my own.
I'm
I
using the
gotta
beaver.
the moment when I have way too many Ivan windows open, so I'm trying to figure out which one of them. There we go. So yeah, like this is in Ivan's console where I have like a Kafka integration here. And if I wanted to include like add an integration, I can quickly make that change and do that there. Um, but that's kind of a different way of looking at it. Like if I have one of my Postgres instances here and I say, oh, I want to add an integration, I can just jump in and then just move some of my logs. Obviously, let's put my logs in open search and it'll look and say, hey, you've got this open search item here, and I can just connect them, do some quick modification to a thing, and then now all of a sudden it's integrated, it's done. And obviously it's gonna require some spinning up and powering down of things. It's inactive now because I don't have the Postgres instance open. That's one way. That's kind of like I said, that's kind of doing it backwards, where you have all the services and you're just connecting them. I would love to see us continue to develop in that direction. I was telling someone earlier, like one of my favorite things to do now is design the schema and using something like DBML and then just exporting it as SQL and then running with it and letting it build all of my schema and things for me. Yeah. It's between separate Ivan services, but we also support some third-party services. I chose some Ivan services there, but you can integrate with things. A really, really popular one is people will send a lot of their metrics to Datadog, and using like Datadog as that kind of the big feature. And then of course, if you have like MongoDB or some of these other services and you want to manage them using tools within Aiven, then you can do that. That's definitely capable. All right, folks, we are at time. I want to thank you, everyone, for awesome questions. I want to thank you, Dirk. Thanks for coming up and kind of clarifying some of those questions for me as well. And thank you, everyone, for jumping in and participating. You've all been fantastic. And again, there will be a recording of this that is distributed out in the next couple of days. I think we have a U.S. holiday tomorrow, so it should be out possibly on Friday. But thank you so much and have a great rest of your day.